back to another Offensive Security C2 series video. In today's video, we're actually going to take it developing our own custom C2 implants and a little bit of C2 server-side code too. So a while ago, I created AgentSmith. Now AgentSmith is just a proof of concept golang implant that makes use of public-facing infrastructure for command and control. This is not a new concept when it comes to command and control, but AgentSmith was a personal attempt at implementing this concept. The idea for AgentSmith is that you really don't need C2 server infrastructure, you just needed a golang implant, which could be run on multiple operating systems and even cross-compiled from one system. This makes a really easy to distribute binary and overall a really versatile command and control endpoint. You see, I can make use of something like Twitter or Facebook or like a free WordPress site or something to actually host my command and control. I wouldn't have to stand up any actual servers or anything like that. And then the way output is sent kind of just depends on how you want to configure it. You could then configure a C2 server, kind of like what we're going to do today. But since I was going for a deployment that required truly no infrastructure of my own, I decided to implement a pastebin integration. So it would actually use the pastebin API to post the outputs of the command. Now, the downside to that, obviously, is that you'll be posting a lot of potentially sensitive system information to pastebin for all to see. You can do things like hide it or even potentially implement private paste, but so overall it's probably not the greatest idea for a professional red team engagement, but it was really good for a proof of concept because you could integrate with other APIs that allow you to do something similar that may be more secure. Now, normally I would just want to write something from scratch, but AgentSmith has some pretty good room for improvement that I want to expound on. So instead of writing an agent from scratch, I'm going to walk you through the AgentSmith code, and then we're going to make some modifications to make it even better. I feel like this will better get the point across of how one could implement their own C2 tooling without actually having to watch me write code from scratch. So the basic usage by default is to set our URL. This is basically the endpoint for the C2 infrastructure. Now, this can just be a web server. You can totally host your own C2 infrastructure and you don't have to use a public-facing service. All the commands are issued through GET request, so that's the only requirement. So it's all HTTP based. The second thing you want to do is set a URL for posting the commands in the send-response handler function. Now this could be the same exact handler if you're doing your own C2, or this could be another location where you actually want to make a post, such as pastebin. Like I mentioned, the pastebin integration has already been implemented. So if you want to use pastebin, all you have to do is turn on a specific flag, and the send-response handler will redirect the output request to pastebin instead. Now to get this to work, I implemented some interesting parsing, and I did this because I wanted to get commands out of like a Twitter post where there's already a ton of HTML and the response body isn't blank. I had to figure out a way to get the response body and then parse through it to find the command that I want. So I came up with this simple little parentheses command syntax. This isn't something that you'll see often on like a normal website, so I found it to be pretty reliable to be able to find the commands that I wanted on a crowded page of content. This allows me to like sneak a command into some page that I've hijacked. There's a problem though. You see, golang's exec function requires each argument of a command to also be the argument that's being passed into the function itself. So to get around this, I created extra syntax to parse out of a given document. As you can see here, command is the root command, tag.la would be wrapped in these arg values, and then the value that you wanted to actually ls from would be whatever your directory is, it's just called value. And ultimately that creates the string ls tag.la/etc in this case. And that was the layout. But honestly, that's really gross, and that's what we're going to fix today. So to fix it, we're going to use this module called shellwords. Now, I found this module by actually referencing the Merlin C2 framework. So Merlin is another Golang-based tool, and it's really awesome. It's a full command and control tool. All the binaries cross-compile for different operating systems that Golang supports, and the server supports like an HTTP 2.0 protocol, and everything's over HTTPS. It's just all around a really interesting tool. It works kind of like how PowerShell Empire does. A lot of the modules are very similar, and the kind of polling system is very similar, and the agent system is very similar. So if you're familiar with PowerShell Empire, it's pretty easy to hop into Merlin. So after using Merlin, I was very confused about how they were parsing commands so easily. Well, their solution was to use the shellwords module. So I tried it out for myself, and it worked pretty great. All this does is take some values you give it and parse out the shell words, so to speak, and comprise your shell statement basically into arguments. How that's beneficial for us is in the context of Golang, it'll build a slice. And the slice will be all of our arguments. Then Golang actually gives us a syntax to expand our slice into individual arguments on its own when passing it to something like the exec function, which is going to solve all of our problems, and we won't need to have weird individual parsing statements. We'll really only need to parse the command and the arguments. So let's dive right into that. First off, I want to break down the program as it exists today. So we've already kind of walked through how it works at a high level based on the README, but I want to walk through the functional implementation. So here we have an import that implements all of our libraries and whatnot that we're using throughout this. As we clean this up a little bit, we'll probably use less and less of these because logging and fatally erroring out will kill our agent, and that's something you never want. We want to handle our errors silently in the case of something like a C2 implant. So we'll change some stuff like that. But overall, this is what we're using. So we're using the NetHTTP libraries to make the actual request, logging for some general debugging output during development, NetURL for URL parsing, IOUtil for actually reading in data and parsing it as well, the regular expressions for parsing out the body for that syntax that we're looking for, strings to do some string modification and casting, the exec module to actually execute commands, HTML to parse out HTML-specific attributes, bytes to do some byte conversion and handling, and time to actually do delays and stuff for our agent. This is not a socket-based or continuous agent. This is a polling agent, so it polls on a specific interval, which we'll look at right away. So the main function is the first thing that runs. This is the core of our program that I'll execute. And the first thing we're doing is defining a delay. And it's a time duration of 10, which is kind of arbitrary, but it's a time duration on purpose because this is how we actually configure and set time in Golang. Then we have this endless for loop. And this endless for loop we'll call the get command function, then sleep for 10 seconds. And basically how that works is we take that duration of 10 that was kind of arbitrary before and multiply it by time.second. That'll turn it into 10 seconds. And we'll use time.sleep to actually sleep for 10 seconds. So we'll pause for 10 seconds and then loop back to the get command function again. So basically this just executes get command over and over again every 10 seconds. We've already kind of explained the arg parsing and how this works. So I won't go over that again. We'll dive straight into the function itself. So this URL parameter is actually where we set the URL initially. Then we make a GET request using the HTTP module. So we'll pass in that URL. We'll collect the response, handle the error if we need to handle the error, and then that response, we actually take it with IOUtil and read it, and we store that in body. So now that we have this variable body, we need to get our response out. So we talked about how we're parsing these commands already. This is where the regex comes in. So all we're doing with the regex is taking the syntax that we've written and parsing that out of the body. The body, by default, I believe, is in bytes after coming out of IOUtil. So we define our regex, and then we use a find string submatch, and we cast the body to a string. This will basically find the substring that matches this regular expression within the context of the body. Once we have that, we'll kind of join it together into its own string and store that in the command variable. Then we'll replace all the little syntax that we used to locate it with nothing, because we don't want the command syntax anymore, we just want the plain command, whatever it is. So this helps us extract that. And that's basically what we're doing for each one of these. We're finding the expression that we're defining, getting the substring of that, extracting that, then replacing the values of the regular expression to get our core value that we want. After that, we define an output variable that's a byte slice. The byte slice is actually returned by this function, the exec command, and we're getting the output explicitly of this command. And that's what's getting stored in out. So this returns a byte slice, which is why we need to define this variable as such. So we define this variable, and then we're doing some simple checks to make sure things aren't empty. And if they are or aren't empty is how we determine what version of the command we run. So if we have a command, an arg, and a value, we'll pass in a command, an arg, and a value. If we just have a command and an arg, that's what we'll pass in. If we just have a command and a value, that's what we'll pass in. And if we just have a single command, we'll pass in that. Obviously, this is very, very limited, and this is exactly what we're going to change today. After all that's done, though, you got to remember we got to send our response. So we collected that output. So we cast it to a string and toss it to the send response function. This function is where the flag for the pastebin integration is defined. So if you wanted to use pastebin instead, you just set this to true, and if it's true, it'll then pass that along to the send pastebin where this is implemented. If you use this, you have to define your own API key and then also define all the attributes you want. So if you want to change any of these defaults, like especially the paste name or the expiry date, that's all on you. But otherwise, you have to define another URL, which could be the same URL as before, but this is anywhere that you want to post this to. Now this is via another GET request by default. So if you wanted to do like a post request, you'd have to re-implement that with like an HTTP post or something like that. But otherwise, we just pass a GET request in the URI, and that's all there is to it. We don't care what values return in the response. We just set that in null and then move along. And then once this returns, we've completed our function, this will finish, and then we'll loop back through again. So that's the basic functionality. And honestly, at the end of the day, that's all a C2 implant is doing. It's a program that is going somewhere to get some data, usually a command that it wants to execute, passing that command into some kind of functionality that will execute it, getting the response, and sending that back to whoever issued the command in the first place. That's really all there is to it. It's that simple. This is just basic programming. It's basic input-output, some basic command execution. That's all C2 is. And I really like boiling it down to that because a lot of the C2 tools that I use day to day as a professional are really complex and they do a lot of awesome things. But when it comes down to the fundamentals of what you need, it's really not that complex to get code execution on a target. And I like that because that makes writing your own custom tools easy. You may not get all the fancy, process injection or hiding in memory. You won't get that out of the box. But if you can define a baseline, you can always build off of that. You can always add in feature functionality, and it's all custom. And that's important for your own tooling, especially if you're looking into red teaming and emulating adversaries, because maybe you need to get around things in a particular environment, and you can't use, maybe like a modified interpreter payload or something. So these are very important skills to have as an offensive security professional, and they don't have to be that complicated. So let's get developing. The first thing I want to do is start using that third-party module of shellwords. So we're going to add that in, and that's all it takes. This will automatically pull this in whenever we want to make, and we'll be able to use it. Now, to actually get this value and set everything up for shellwords, we need to define a few things. So we're not really going to need this value line anymore. We can get rid of that. All we really need now is command and args. So we're going to define an args, kind of like they had in the example. And this is going to be a shellwords.parse. And it's going to take our arg. That's kind of all we need to set up for that. Everything else should be pretty much good to go. We want to parse things out the same way still, but the difference in how we use this is now dramatic. Instead of having to define commands like this, where we say, maybe we want command ls, we can say, maybe we want command. So instead of defining commands maybe like this, where we say command, ls, and then we need arguments, so we do arg, attack LA, and this probably isn't the best example, but just to keep it going, maybe we had another argument for attack H. So maybe we didn't do attack LA H, maybe we did attack LA, attack H. I don't even know if that works, but currently that's how we have to define multiple arguments, and that's really gross. And that's not even considering adding the value parameter of a specific directory or something. What we're changing this to now is we can have a single arg, and we can define everything on one line, which is so much better. We don't even have to really worry about anything. Now the caveat here is that we can't just type in a command like ls attack LAH. And we really wouldn't want to, because you got to remember the intent of this particular implant is to be able to parse things out of a particular page. We could refine this even further into a command. And then once we get this value, we could actually parse out the first part and put it in its own command, and then the second part. So that way we would only have to write one line like this. But that's not what we're going to do today. We're just going to implement the arguments, and that's something we could do at a later date. But at the end of the day, it's not as beneficial as this initial change. So let's get rid of all this text. Alright, so now we need to handle this error, because Golang likes it when we handle our errors, and so do good programming practices. So here's my first change. I'm going to do the log fatal error like we have been, but I'm actually going to comment that out, because we're going to start returning 0. And the reason for this is, while it's good to know what our errors are during development, once we actually run this implant, we don't want to stop. A log fatal error will actually kill our program and stop it. We want to keep looping through even if something doesn't parse correctly, or maybe it fails to hit an endpoint or something on a particular polling interval. That's going to hurt us more than it will help us, because maybe it's functioning fine and our C2 went down. We don't want our agent to die just because we lost control over a C2 server or internet connection went out or something like that. We want the agent to keep running, so once we get back up, it'll pull back in, right? But there is some modification that we need to do here. And I'm going to cheat a little bit because I have some code pre-written to the side. And we're going to get rid of all of this and replace it with that. And what's going on here is basically the shellwords parse is returning a slice. So we need to check if the length of the slice is greater than 0. That's how we know if the args are empty or not. Everything else is about the same though. We're just checking if the command is empty. And then the difference here, and what makes this cleaner, is now we're taking the command, passing that in as the first argument, and then auto-expanding our args. I need to modify this a little bit because we have a lowercase s, but otherwise, that's all there is to it. And then we're checking if it's just a singular command, because if this check fails, we still want to see if there's, if I ran ls or an ID, and get that command. Awesome. Everything else can pretty much stay the same. Now, we did just modify the return, which means that our function actually needs to return something. which right now it doesn't return anything. So let's define our return value as an int and start working through anywhere that we're handling errors and do the same thing. So return 0 here and comment this out. And to make our lives easier, we're just going to copy and paste this. That's good there. That's good there. While we're here doing this, we'll replace this throughout the project. In this case, we'll change response status code where it should be, just in case we want to uncomment that while we're testing. But since we're modifying all these things, we need to make sure that we are accurately handling these errors. Cool. So we're cool with returning 0. You should probably actually return like a 1 or something, but this is how I'm going to have it for now because it'll work just fine. And one other thing I need to do is also return 0. Cool. So I've saved those changes, and now we can comment out log, save that change as well, because we're no longer using log anywhere. In fact, I don't think we're using any kind of print functions anywhere either. Format print line, fix that. Yep, doesn't look like we're using any kind of string format. Oh, okay, that's already missing because we didn't have it in there. I'm going to add that back, so if anybody uncomments that, also need to add some returns right here. You all are getting to watch me do a little bit of live programming, even though it's pre-recorded. I'm going to leave all this stuff in because this is the process for it. It's important to see. Alright, so we should be okay to compile this. So let's open up the terminal real quick, and we'll just run a make. Oh, okay, so we have an error in our Makefile. That's a great segue because I wanted to show the Makefile next. So the Makefile by default is configured to automatically compile for each major operating system. So a Windows agent, a Linux agent, and a Mac OS agent. Looks like we have a line in here for server driver. A lot of this project and a lot of the configurations were heavily influenced and inspired by the Merlin C2 framework. So you can clearly see some areas where I copied and pasted and didn't correctly make all the modifications I need that weren't applicable to this project at all. But the Makefile was a big one where I could really directly use a lot of the same commands because it's just a Makefile. And the biggest thing I wanted to take advantage of was all the flags that they had figured out how to define. So that way we don't have things like some kind of GUI popping up on a Windows box or something. So cool, we just need to remove the server Darwin because there is no server, it's all agent-based stuff. And all this does is define all the flags and compilation steps that are necessary to compile the various binaries. It's pretty cool. So we're going to run make again. If we just wanted to compile an agent for OS X, we could run make agent Darwin. But what that does is creates a builds directory where we can see, here's all our binaries. Really awesome, right? And apparently we had no errors, which is the even better thing. Okay, so what we need to do next is I'm going to define our URL to be just our localhost for now. And we're going to do localhost on port 8080. And this is where we're going to both send and receive commands to. So we're not going to use pastebin, we're just going to use this, and so we'll define our URL in both of these places. So we're going to make again to compile this real quick. But then the next thing I'm going to want to do is actually define a basic C2 server. Now I've got some code for a simple C2 server over here. All I'm doing is using the Python simple HTTP server and then handling the GET request to manually parse out the values I want. So we're going to call this simple C2.py, save it alongside everything else. And this is actually from another project. So I'm going to go ahead and remove some of the code I know I don't need, and then we'll get it running to see how our agent interacts with it. So the first thing we don't need is this agent check-in. We're not implementing any kind of check-in at this point. We do want to check out the path, This basically says if anything exists in the path, let's parse it, unquote it, and get that, which is important because the output that we'll return will all be in our get path in that case. Then it prompts us to execute for another command, and we'll see how that loop works in a little bit. So here we need to define our C2 address, which we're wanting to listen on 8080. And we'll write. And I will just walk through this real quick before we execute, because we're going to be making some modifications to this as well. So of course we run. So our run here is basically our main. We get some nice friendly output. We define a server address where we want to listen, and then we configure an HTTP server. So if you've ever done the classic, Python 3-m http.server syntax on the command line to define a quick and simple HTTP server for either infilling or exfilling data, this is the same thing. We're just doing it all programmatically so we can modify this and manipulate it in better ways than just that. In fact, the original proof of concept for me testing AgentSmith was just defining an index.html with the proper commands being parsed and then serving that. And then I would have to make modifications to the index.html anytime I wanted to change a command. This gives us a more interactive prompt so we don't have to vim and change a file every time. We can literally just type a command and hit enter. It'll let us know once we've initialized the server and it'll start serving it. And then from then on we kind of hook into this class and use the doGet method. And this doGet method is going to let us intercept everything that comes in a GET request. So like I said here, you're able to get the path value from self, which is the request object itself, parse that out, and then we're actually able to receive your user input so you can actually interact with the command line. From there, we actually need to send a response. So we'll send a 200 response, that way the HTTP GET request function in golang knows that we got a successful response. We'll send some basic headers back. But then the most important thing is that we need to take that command that we input earlier and write that to the page. So this is kind of like writing to the response. We're able to dynamically change the response by using this wfile.write. So this is basically like creating an index.html on the fly, and we're able to modify that with our input. Then this will kind of wait for the next GET request, prompt us for input command, and you're good to go. Now there is an inherent flaw with this that we're not going to address in this video. In fact, I issued that as a challenge to you to see how you would solve it. That flaw is with a polling agent like AgentSmith, it's going to check in every 10 seconds, which means every 10 seconds, regardless if we enter a command or not, this doGet method is going to get called. So if we sit and listen and then issue a command and we get a response, that's great. But if we then get another response and prompting us for another command and then wait too long, and then the agent checks in more than once, maybe we waited 20 seconds, now the agent's kind of out of sync. It's not getting any responses back, and we're having some kind of error handlings, and there may be some delays in place. The polling rate doesn't match what you get, and we're not doing any handling for that situation. So it works, but if you don't handle the commands right away, you could run into potential issues after the agent's checked in one too many times and you don't interact with them. The other glaring issue that we are going to address today is how to write the command correctly. So we need to be able to pass a command down in the syntax that's required for AgentSmith, which is in that command and arg functionality. And I have not implemented that yet, so this is going to be interesting. So the easiest way to do this would be able to make a command variable and an arg variable, and then we can kind of cheese it that way. But I don't know that that's what I want to do. I think I want to actually just give the easy prompt, so all the user has to do is type in like lstack.la, and then we'll handle it from there. So we're going to do a little bit of Googling. We're going to see how to get the first item before a space Python. This is probably going to be some simple string slicing, nothing complicated. And what's nice about Python is you can just kind of treat strings like arrays sometimes, so we can pretty much parse things out pretty easily. So looks like our string split function will let us do that. So we'll be able to define the split as 1 and break this into 2 parts. So we can give that a try. So I don't think we have to import anything fancy. We'll find out real quick. So we'll define command, we'll call it command list as command list as command.split, and then we want one is split, and then we need to do it on a space. So we will then take that and no, we need to flip this around. I'm doing this wrong. So we need to say command. This is our command list. And we'll say command list split 1. And so that'll give us our command. Wait, no, I don't know the first time. This will give us our command list because this will give us each item. So now we want to redefine our command as this command list, and we want the first property, and then we want to take our args, and we want to make that the second property, and that should be right. And now we actually should be able to make this pretty simple. So to give our syntax in, we just need our command, and we can concatenate this. And then we can have our arg, and concatenate that. And redefine our command as command plus arg. And basically that'll make a string that is this and this, but that shouldn't matter because our regular expression should be able to parse those out, so we don't care how it really looks on the page. And then we can leave the rest the same. And in theory, that should work okay. I may be forgetting something that you all might notice as I'm going, so we'll find out how that works. Okay, so we'll do a quick tmux so we can split some panes here. Alright. So we've got her going. I want to make this real quick just in case I did something wrong. Builds. Alright. And then we'll go over here and we need to run Python simple c2.py. Have an invalid syntax. I didn't concatenate this string correctly. See, already got our first mistake. No problem. Let's try that again. Alright, our server's initialized. Now we just need something to call back home to it. So we will execute our agent Darwin and see how it goes. Looks like it's running. Hey, we got a check-in, so. Alright. There's our first error. So because I only issued one command and not a command with another argument, we ran into a problem because this index didn't exist. Right, so now we have to do some handling and some checks. So we could say an easy check might be if the length of command list is greater than 1, then we can define this. And we can also loop this in here too because there's no need to concatenate it if otherwise. Because otherwise we'll just have a single command. And that should be an easy check for that. Let's try again. And our agent should still be running unless we had any weird errors. Nope, still running, so we did all our error handling correctly, and there it is. Check this. Now we run ls. Not supported between list and int. So we probably have some type conversion issues here. So it's possible that we may just need to cast this as a string. Make sure I'm doing that right. So we'll say cast as string in Python. I believe that's the right syntax. Thought it automatically did it. SSDR. Cool. Go ahead and handle that. And also kind of want to print this out because I want to see how it looks. So in this case, we'll print CMD. I guess in any case, we can just print CMD because it'll always be CMD. So we'll print CMD. Cool. And now we just wait for the agent to check in. Still not liking that, huh? Ah, I see what we did wrong. If statement in the wrong place. Alright, cool. Let's try this again. In software development fun, everyone. Wait for our agent to check in. Got to check in. It worked! And look at that. It executed the command and gave it back to us. So that means our parsing is working correctly. And that means we've generated all this correctly. Now let's actually get something with an argument into it. So let's try this. Alright, and now you can see the crux of that issue I was talking about earlier. Good news is, looks like we built our argument string correctly. The bad news is, doesn't look like our agent has checked in again, so now we can try it, see if it works. Awesome. Okay, so it's not that huge of an issue, but it is still a potential problem. But cool, that didn't take a whole lot. I thought that was going to be way harder. So that's our simple C2 server, and that's also, of course, our simple C2 agent using AgentSmith. So I've done everything that I wanted to do with this, and hopefully you all can see how you can easily develop your own custom tooling. It really doesn't take a whole lot. It's all about understanding the fundamentals of, I need to make a request to something, and it needs to send a response. And then you can do whatever you need with that response. If it's executing a command, you can execute a command. If it's passing it to some other functionality to build something, you can do that. It's all basic programming fundamentals. So you can tell somebody that you went and learned how to write malware today, but that's kind of in quotes. You really just learned how to write some basic input-output software that executes commands. This is no different than doing like a basic computer science programming project where you need to pass something to the command line. That's all C2 is at the most fundamental level. With that, I hope you all learned a lot today, and I hope you all enjoyed this. I'll of course push off all these code changes to AgentSmith so it's out there and available. AgentSmith is open source, so if you want to contribute to it and do some cool new things with it, that's perfectly awesome. I'd be happy to review those pull requests. Depending on when this video comes out, there may or may not have been some channel announcements yet, but either way, there's a merch store now for the channel, and there's also a Patreon. So check those out if you're interested in supporting the channel further. Otherwise, like and subscribe, comment, all those interaction things if you feel like doing that. And ultimately, thanks for watching.